Hi, thank you for taking the time to visit the Physics by Dr. Paert channel. This video demonstrates the solution to problem number 1 and 2 from Module 2.1. Let's see the first problem in the Module 2 Part 1. While driving a car at 90 km per hour, how far do you move while your eyes shut for half a second during a hard sneeze? The assumed constant speed is 90 km per hour. To convert its unit to meters per second, you just need to divide it by 3.6. If you want to know why, look at the cloud space. So, the speed of the car is 25 meters per second. Distance traveled at constant velocity is calculated as product of velocity and travel time. Thus, in half a second, the car travels a distance of 12.5 meters. Look at the problem number 2 in the Module 2 Part 1. Compute your average velocity in the following two cases. In first case, you walk 73.2 meters at a speed of 1.22 meter per second and then run 73.2 meters at a speed of 3.05 meter per second along a straight track, covering the same distance at different speeds. In the second case, you walk for 1 minute at a speed of 1.22 meter per second and then run for 1 minute at 3.05 meter per second along a straight track, resulting the same travel time at different speeds. The final step of this problem requires you to graph x versus t for both cases and indicate how the average velocity is found on the graph. Average velocity in the general case is calculated by dividing the total distance traveled by the total travel time. Taking advantage of the fact that time is equal to distance divided by velocity while the velocity is constant, we can see that the average velocity is 1.74 meter per second. Using the fact that distance is equal to velocity multiplied by travel time for constant velocity, we find that the average velocity is 2.14 meter per second. Here are the graphs for both cases. The first graph on the left consists of two solid line segments. The slope of the first line segment is 1.22 and the slope of the second line segment is 3.05. The second graph on the right also consists of two solid line segments with the same slope as before. The main difference compared to the first graph is that the fast moving phase lasts much longer. The slope of the dashed line represents the average velocity for both graphs. Leave a comment below if you have any question. Don't forget to hit subscribe, like, and notification bell buttons to be notified about our future videos. Please share the video if you like it. Thank you again to watch this video and see you later.